So the next part of the extensions is to simplify radicals. In other words, if you're solving the quadratic formula, you're often going to end up with a square root that's not perfect. It's not a perfect square. And if that happens, you can write your answers in decimal form. You can just take your calculator and find the answer, but you can also see what this says, leave it in simplified radical form. So we're going to talk about how to do that. So we're going to start with this, 5x squared minus 16. And when you do that, you're going to go x equals negative b. Now you notice there's no x term, so b is actually 0 here, a is 5, and c is minus 16. Okay, so minus b becomes just 0, plus or minus the square root of b squared, which is 0 squared, minus 4 times a, which is 5, times c, which is minus 16. And then it's all divided by 2 times 5. So what that gives you is the 0 is going to go away. So we can just have the plus or minus square root of, and then this 0 is gone. And if we take our calculator, we can go, just move it out of the way so you can see what I'm doing. The two negatives, minus and minus, are going to give us a positive, and 4 times 5 times 16 is 320. So I'm just going to write 320 in here, and then I'm going to divide that by 10. So the question then is, how do I simplify this, the square root of 320? And what you're going to try to do is you're going to try to find a perfect square, the biggest perfect square you can, that goes into 320. Okay, so perfect squares are, 1 squared is 1, 2 squared is 4, 3 squared is 9, and then 16, and then 25, and then 36, 49, 64, 81, 100, 121, 144. That's 12 squared, then it's 169 and 196 and so on, okay? So that's 13 squared, 14 squared. This is 225 is the next one, and then after that you can kind of keep going. That's 15 squared, so 16 squared is 256, and then you keep going. But here's what's interesting about this. We want to see which of these numbers, okay, goes into 320. Can I find a factor of 320 that is one of these? Okay, so I'm hoping I can. The first thing I'm going to do is actually take 320 and divide it by 2, okay? And that's 160. So I know this, the biggest perfect square that could possibly go into it is 160. Now 160 is not a perfect square. So I'm going to say, okay, what's 320 divided by the closest perfect square, which is 144? And that doesn't work. So then I say, okay, well, 320, what's that divided by 121? Does that work? Nope. 320 divided by 100. Nope. And what I'm saying is it doesn't work. I mean, it doesn't work in the sense that it's not a nice number. It's not a perfect number. So I keep going until I find one that works. And this one's going to work. Okay, so 64 is a perfect square that goes into 320. So what I'm going to do is I'm going to go plus or minus the square root of, and I'm going to write 320 as 5 multiplied by 64, okay, divided by 10. And that's going to allow me then to now take the square root of 64. So the square root of 64 is 8. So I'm going to be able to say that's 8 root 5, okay? So I'm going to take this square root and move it outside, and then I'm going to divide by 10. And then what I can do is I can simplify 8 and 10. I can reduce that to 4 root 5 over 5. And that's my simplified answer. Okay, so that's how you simplify radicals. So we're going to try to do that again. All right, I'm going to just erase this. You can pause the video if you want to write it down or see it done, but I'm going to erase this. I'm going to leave the perfect squares there, and I am going to do another one. So I'm going to try this one. 3x squared equals 2x plus 2. So we're going to go 3x squared. Oh, you really can't see that. Let's try this again then. 3x squared equals 2x plus 2. So the first thing I'm going to do is go 3x squared minus 2x minus 2 equals 0. Okay, so that's the first thing I'm going to do. That enables me to get it as a quadratic. Then I'm going to say a is 3, b is minus 2, and c is minus 2. And I'm going to plug into my quadratic formula. So x is going to equal minus b, so 2, plus or minus the square root of b squared, so that's minus 2 squared, minus 4 times a, which is 3, times c, which is minus 2. And I'm going to divide that whole thing by 2 times a, and a is 3. All right? So that gives me 2 plus or minus the square root of 4. That's minus 2 squared. 4 times 3 is 12, times 2 is 24, so 4 plus 24. And then it's all divided by 6. And I'm going to just jump over my perfect squares here. So it's 2 plus or minus the square root of 28 divided by 6. Okay? Now, I'm looking for a perfect square factor of 28. So it's got to be one of these smaller ones, and the one that works is 4. That's the perfect square factor of 28 because 28 is 4 times 7. So I'm going to write that as 4 times 7. And then, just like last time, I'm going to take the square root of 4. So what is the square root of 4? It's 2. So I'm going to write this as 2 root 7. Okay? Divided by 6. And then the last step is going to be to take these 2's and divide them out. So in other words, that's going to be 1 plus or minus root 7 divided by 3. I'm going to divide everything here by 2. So those are going to become 1, and this is going to become 3. Okay? So that's how you simplify your radicals. You're always looking for a perfect square, and you can see down here those are that's where the two answers came from. So each time you're going to try to get this number to be a perfect square multiplied by something. Okay? You can usually tell what the perfect square is going to be by looking at these numbers, because these are both divisible by 4, so then I knew that this would be divisible by 4. But we'll do one more example just to show you again, and then you can try the rest of them on your own if we have time. What time? Yeah, so we should be able to do another one. So let's take, we'll get rid of these things, and we'll try the third one. So the third one says 2 is equal to 3x squared plus 8x. So the first thing I'm going to do, just like I did with the other ones, is I'm going to try to get them all on one side. I need them all on one side. So I'm going to have, let's get rid of these. There we go. So I'm going to have number 3 here. I'm going to bring it up here to start, and I'm going to get 3x squared plus 8x minus 2. All right, I'm just going to bring the 2 over. So then x is going to be, the a value is 3, that's a, b is 8, and c is negative 2. So we're going to have minus 8, because that's minus b, plus or minus the square root of 8 squared minus 4 times 3 times minus 2. All right, and we're all going to divide that all by 2. Whoa, 2 times 3. Okay, let me see if I can get to that. A little crazy there. Let's try that again. Straight across. There we go. 2 times 3. So that's going to give me, I'm going to jump down here. That's going to give me minus 8 plus or minus the square root of 8 squared is 64. And then 4 times 3 is 12, times 2 is 24. So you're going to have plus 24. And we're going to divide that whole thing by 6. So now I'm going to have minus 8 plus or minus the square root of 88 divided by 6. Okay. So then I'm going to try to find the perfect square factor of 88, or a perfect square factor. I know 4 works, so I'm going to do 4. All right, I'm going to go minus 8 plus or minus the square root of 4 times 22. Okay, because 8 is just 4 times 2, so I know it's that. And I'm going to divide that by 6. And then I'm going to take the 4 out. So that's going to give me x is equal to -8 plus or minus 2 root 22 divided by 6. Now the question is, can I reduce the 22 any further? So it has to be a perfect square. So 1 goes into it, but that's not going to change anything, so that's not helpful. 4 doesn't go into 22. 9 doesn't go into 22. 16 is also not a factor of 22, and 25 is too big. That's actually as low as I can reduce that. So what I'm going to do then, that's my answer, but these are all, this 2, 6, and 8 are all divisible by 2, so I'm just going to divide them all by 2, and that's going to leave me with 4 here and 3 there. So my answer is -4 plus or minus the square root of 22 divided by 3. Okay. You can try the rest of them. The answers are down here. So you've got 3 more to try. But that's how you simplify radicals in the quadratic formula.